Hello, and welcome to SerilDB stream number 15, where we'll be looking at vector embeddings. So, big topic here today, joined by Emmanuel. Emmanuel's been working on the full text search indexing, traditional indexing, alongside the newly released, in beta at the moment, vector embedding functionality. We've got some exciting updates to share today. And yeah, Emmanuel, welcome. Thanks for joining us today.
Thank you, Toby. Thank you. So let's start by sharing my screen, and we are going to dive into embeddings in Seril. So the first thing I would like to say is it's not new. We already have vectors in Seril, and in fact, what are vectors? Vectors are arrays, right? Arrays usually of numbers. And you were already being able to store embeddings in SerilDB. So you are probably already familiar with the syntax that we use to create objects and create records in SerilDB. So when you are using create with the name of the key to your record, you can set a value, and this value can just be an object. And this object will be an array, and this array will contain numbers. And here are our vectors. So this was already working, and you were maybe already using this feature. You can, of course, retrieve the object. It's a record like any other. Here it's integers. It's pretty common to have float as well, right? So it's just an array of numbers. So storing vectors in SerilDB was already existing. But you also add some functions, and we have now a whole set of functions that let you manipulate the vectors. So you probably know already also the statement update. With update, you can update your record. You set a new value for the fields that you want to update. And in this case, we want to add a value to a vector. So we use this set of functions. So we have this new package vector that contains a list of functions. I will enumerate them a little bit later. Vector add is doing addition between vectors. So we are just saying that the object field in the vector record is going to be added this other vector. And we are adding this vector of 2, 4, 6, 8, right? And it returns the updated record. So my vector 1 is not being updated it becomes 3, 6, 9, 12, right? Because adding 1, 2, 3, 4 to 3, 4, 6, 8 exactly does this new vector. Okay, so this is about manipulating vectors. Here we even add this value to every vectors that was existing in the table vector, right? It's really powerful. You can update millions, thousands of rows with just this statement and apply a function to your vector. Okay, manipulating vector. The package vector contains now a nice set of functions. So vector add that lets you make element-wise addition. So each item in the vector are independently added. Compute the angle between vectors, making the cross product, divide, make the dot product, compute the magnitude, multiply, normalize the vector. You can project a vector to another one, and you can make a subtraction. So they are the pretty common functions that you may want to use when you want to manipulate vectors.
I just want to jump in there, Emmanuel, and say all of these functions that Emmanuel is showing are available on the new documentation site, which launched today. This is available on docs.serilDB.com, and you can see all of these functions under SerilQL and functions and vector. So with examples of how they all work. So if you want to have a look at this while you're listening along to the stream, then jump into that section there that Emmanuel's got on his screen.
Exactly, that's the one with a nice light mode and a nice dark mode. I like the dark mode. So each function is indeed described here with examples, and you discover at the same time a function related to vector search that we are going to see exactly now. Okay, new package. Distance and similarities. So this is something that you want to use with the new feature that I'm going to present in 2 minutes, where you have a computation of distances, so Chebyshev, Euclidean, Hamming, Manhattan, Minkowski, and similarities like cosine, Jacquard, Pearson. This brings me to vector search. So we just saw how we can manipulate vectors. In the release 1.0 of CyrilDB, we have introduced what we call an experimental feature, which was vector search. And vector search came with the first implementation based on an index called M3. This index is an index that speeds up your query when you want to make a nearest neighbor search, and it was equivalent. It was an exact search, right? So this is something that was available from 1.0.0. And the limitation currently that you have with the M3 index is that it supports two kinds of distances, Euclidean and Manhattan, and you cannot use the other computation distances or similarities. So we now have a new implementation that will come in not yet in the nightly today, but in few days. So we are just merging this feature. So it will be the next step for this experimental feature about vectors, where we have now a brute force implementation. Brute force means that we are going to compute, to calculate, to search for the closest neighbors over the whole set of records. Which can be it can be seen as something scary, but in fact, with a key-value store like CyrilDB, it's really fast, and you can compute that in really fastly. In milliseconds with thousands, hundreds, even millions of records. So it's something that is really handy and useful when you want to validate a model and you want to check before going in indexing or before putting that in other kind of indexing where you lose information, like HNSW. So in this case, you can just validate that your model is working well, and you can make that up to really a large number of records. So brute force KNN works with exactly the same operator that you have seen with M3 indexes when it has been released a few weeks ago. With one difference is that because the M3 indexes contain, you explicitly define which distance you want to compute, which can be Euclidean or Manhattan. Here, in this case, we don't have an index that tells which distance or similarity you want to use, so you have to explicitly put it in the operator. So you have the KNN operator, which is this one, with the number of records you want to get, and which distance you want to apply, which can be one of the 10 that we saw previously. So in this case, we use cosine. We give the vector the reference, and we get as a result the records that are closest to this vector. It's a normal SQL statement, right? There's nothing specific. The only specific thing is that we have an operator. So it's pretty handy because it means that you can use every other capabilities of the select statement, grouping, filtering with other predicates, and so I will showcase that just after. Okay, brute force, and then symmetric M3 index is the one I was talking just before that we released already on 1.0.0, which is simply an index definition, and then you would use the KNN operator without having to put any distance because it's already defined in the statement. Okay. You also have the ability to use to project any information. So you can use vector distance, the functions inside the select part of the statement, and you can just print the distance. So in this case, we are printing the Euclidean distance. It's pretty easy. Okay, so this is where we stand now. The next step for neighborhood search is to have HSNW implemented. So it will be it's a search that is approximate. So I need much faster.
It might be a good point, Emmanuel, to just break here really quickly and just describe the differences of what exact nearest neighbor search and approximate nearest neighbor search offer for people when they're building their applications. Obviously, you've got the benefits of speed for the approximate, but it actually has downsides in some regards as well. So specifically for when people are building those applications and obviously comparing us or SerilDB to other implementations which might only implement HNSW or approximate nearest neighbor search.
Yeah, exactly. So the point is that usually you want to check that your model is working well with an exact implementation, because we want to be sure that the results are correct, and it gives you a reference of what are the right results. And once if you need more performances, which is not always the case, right? But if you need more performances because the brute force or the M3 implementation would be too slow, then you want to evaluate another kind of indexing where the result may miss some vectors, but it can be fine, right? Depending of the kind of application that you are building. So in this case, you can use HNSW where the performances are a magnitude, right? It's about 10 times, 100 times, 1,000 times faster, depending of some parameter that you will set that give how far the approximation is. You really have the ability to manage that. You can have something that will be slower but close to the exact result, or you can have something that will be much faster but far from what will be the exact result. So we call that recall. And there is a benchmark called ANN that lets you see. So recall is kind of percent of the number of vectors you should have found, and what is the real number you found, which is a kind of percentage, right? I found 40% of what I should have found, or 60%, or 80%. So it's a setup that depend on it's a benchmark that you have to do with your application, and you decide at some point where you set this approximation. So this is what HSNW gives you, and usually it's the next step after you have set up your application. Does it answer?
Yeah, no, that works well. I think that's understandable. We've got a question here. Maybe you're going to answer this a little bit later on, but there's a question which I guess we're always going to ask, which is about the storage size on disk of vectors. Obviously, storing those within document objects or records, and what is the overhead there because of that document-based approach?
Yeah, so yes, the records are stored. What is the overhead? I mean, do you want? I mean, I don't have yet the exact information about the overhead and the size. What is sure is that we try to, and probably you can answer to be regarding the storage of the vector itself. What I can say about the index is that we try to use compression and try to use numeric value. So we try to find a way to make that as compact as possible. So I cannot tell yet about the HSNW implementation. On the M3 implementation, we are using some compaction, typical numeric sequence compaction. That makes things a little bit compact, but of course, it's there's other things to have in mind is the usage in memory and the usage on disk. So for now, it's really the beginning of this implementation where we didn't yet really optimize the storage. But the next step is indeed to think about, as an example, do we need to store the vector? I mean, as soon as it is indexed and we just want to return the record that is concerned, we may not return the vector. So there is options in SerilDB where you can insert a value that is volatile, right? That will not stay. So there is many opportunities in SerilDB regarding storage, not storage, compacting, compression. And we're happy to get the feedback from the community regarding that and regarding what the community is expecting about this.
Yeah, just to build on that, Fergus, thanks for the question. In SerilDB, we, in order to ensure backwards compatibility, we have a certain number of bytes per record and per data type within that record stored or used for storing the version of that data as well. But the vector itself is something we're going to be optimizing over time as well. So effectively, you've got the document surrounding that, and that's a benefit as well as a negative aspect to it as well. So obviously the negative aspect is you're storing more data alongside that vector, but the benefit is you've got that vector sitting right next to your data. So you're not having to go across the network to another database. You're not having to store that in a separate instance or storage area. You're having that data sit right next to your record data. So you can actually, when you search and when you bring out a record, you've got the record data alongside that that index as well. But yeah, we'll be optimizing that over time so that vectors specifically use only the exact serialization data that they need rather than the versioning information as well. We've got jump back even further, Emmanuel. What are vectors used for? This is a big question. I mean, vectors been talked about a lot over the last 6 to 8 to 12 months. Probably popularized by Pinecone and Quadrant. But what are the uses for vectors and why do they exist? Why can obviously in an AI context, why can we not just store text?
Okay, so I have a demo. So I will give an example because I think there is nothing better than an example. So if you let me, I will go with the demo. You will understand why we need vectors, and yeah. So I have made this. So I guess we are all comfortable with Visual Studio Code, right? So I'm going to show you my environment there, but you are going to see that's pretty simple. So vectors is a way to encode features, right? So in the AI world, we train models and we build vectors, which are, of course, just this sequence of numeric values. But in fact, they are a progressive construction that, with training, I mean, this vector is like something that is affinated after time, right? Each time there is a new training, new information. Each time the model improve, the vector and the suite of number in this vector give more information. I will give an example, which is face recognition. When you use face recognition, you want to extract features like, and you have to detect a face. You have to detect, the position of some angles, of some typical things that you can recognize in an image. So I will show you just a quick example of how to use face recognition with Python and SerilDB. So here's a simple script. Let me show you the script, which is here. Okay, so here's a Python script where I'm, and by the way, it is something that you will be able to do also with the ML part of SerilDB soon. But at this moment, I show you a way to do that in Python. So this is a simple script that is going to index those two images, right? And we are going from these images to extract the features of these images, which are features that expect to detect a face, right? And so this script is pretty simple. We are using something called FaceNet, which will extract the feature. So when I'm indexing photos, I'm just passing my two photos, and am I using this function, which is extract features, which is which is pretty simple. It's here. I read my image. I use the embedder, which is FaceNet, and what is this thing is going to do? It is going to identify in the image how many faces there is, and for each face extract the feature, right? And so it's pretty simple. When it finds faces, I try here to find the largest one. There is only one face in my images, so it's simple. And then it generates a vector that defines the face that has been found in this image, right? So it's pretty simple. And I will run it. Here we go. So I have this. So to run this script is pretty. Here we go. There is a README, and by the way, this script is visible. I will share the link after. So let's make the indexing. So indexing has been started. The main thing is that it's going to extract the information, the feature, which is a vector, and it has now stored my vector. So one vector for Emmanuel JPEG and one vector for Rux JPEG. So if I go there, I can, by the way, see my photos. And I can see that I just have my two vectors. So it's a big vector, right? It's a vector of 128 numeric values. And I can also just see what I have in my database. In my database, I just have 3 records. Oh, sorry, not the right place. Here we go. So I have a photo of me and a photo of the rock with an ID that has been generated. Right. So now what I can do is I can use again my script, and I can just make the face recognition. So I have 2 other images. This one, which is again me, and this one, which is the rock. But they are not the same image, right? They are different images. They are not the same. This one that is the one that has been indexed, and this one that has been indexed. So now I can use my script again by giving the path to my sample. So let's do that. We'll go to my README. Here we go. So I give my script again, but this time I give him the path to the image that I want him to find the face from. Here we go. The script is extracting the vector, making a KNN search, and giving me the image, right? So this was the one indexed, and this was the one I submitted. And fortunately, I find the right one. And I think if I give the other one, which is the rock 2, it should indeed find, yeah, sorry. This is because it was already open. Make it again. Okay, here we go. So if I find the right one, and the query that does that, and to show you how simple it is, the query that does that is this query: select path from photo, where air is my object, in fact, my vector. I want to find the first one using Euclidean, and I pass here my vector, which is a vector that FaceNet and generated from the photo. So you submit a photo to FaceNet. FaceNet generates a vector. This vector, in fact, is the detected face, and you put this vector in your table, and then you do a KNN search with the photo you want to check, with again the same vector extracted, and the first image of the KNN search is supposed to be the closest one. So it's absolutely simple. So AI and vectors. Many AI model are generated features, and features are especially a vector. And finding something that is close to this feature, an object that is close, is finding the proximity between these vectors, which is exactly what the KNN search is about. Sorry, that was a hard demo, but I will share the link, and I think once you will see how simple this project is with Python. And I mean, there is 10 lines of Python and SerilDB with KNN. You will see, and there is so many different use cases that you can use. So it was face recognition, but there is so many other things that you can build from that.
Yeah, that's look, awesome demo there. Just to jump back a second more. So yeah, I think, did you say that had 128 floats inside that vector for the face?
Yeah.
So just to put it in perspective, an OpenAI embedding. So if you push a piece of text, a document, and you try to get an understanding from OpenAI, its API, they'll give you back a vector of floats with 1,536 elements, I think. So every single platform is different, the amount of accuracy or differentiation in the data. But yeah, you can do effectively, vectors can be used for a whole range of things, from finding terms which match or are close to, or similarity search, from being able to in the same way for whether that's imagery or text, or also for generation of data as well. So I hope that answers your question, Chobi. Are the vectors in the photos collection for the training data? I think they are. Yeah, we're going to be pushing that onto our examples repository soon, so you'll be able to run that as well yourself and run it with your own data sets. And just to reiterate, this is using, at the moment, Emmanuel, this is using the exact nearest neighbor search, which is more accurate but also slower. So we'll be introducing more faster, improved performance vector search over the next few months as well. So yeah, some exciting stuff. If you've got any other questions, anybody, then feel free to ask away. Otherwise, yeah, Emmanuel, where do we go from here?
So I can show you something also. I mean, yeah, something interesting regarding vectors. The fact that, and I will make a quick demo of this. The fact that we are integrated as a database, right? That vector is part natively of what the database is doing, means that you can really use the database as a foundation for vector storage. And I wanted to showcase this thing. So the main thing is that a vector is a field like any other. So if you have vector, you can add the metadata regarding to this vector, right? So in this case, I just have created 4 vectors, and well, of course, I'm not in the right place. Here we go. Yeah.
While you're doing that, I think it's important to add in, you can have multiple vectors inside a record. You could have 3 paragraphs or a whole chat conversation with the vector embedding right next to each piece of text for a chat thread or anything like that. So really, again, it comes back to the flexibility of Surreal, and that enables you as a developer to choose how you want to store that data, depending on how you want to query that data later on. So, so yeah, as Emmanuel said, you can store the vectors right alongside the metadata, or you can store multiple vectors alongside that metadata.
Exactly. Also, I'm just the demo effect sometimes, So here we go. So I'm just here we go. So I'm just creating 4 vectors and I mean 4 records that contains a vector called object and a country, and so I can make my NN search here, right? So I'm going to find the closest vector using the cosine similarity this way. But maybe I have different sets of records, and I want to filter them, right? So it could be you have a first model trained with a version. You could have the version of a model trained 2 years ago, or 6 months ago, or 2 days ago, and you would like to compare this model, and then rather than having to make another database to feed another. So you can just use a filter. So in this case, I can just decide to filter on country. So I want only the one in the UK if they would be profiles, right? And I can do that. What I'm doing wrong? Yeah. Here we go. Yeah. Okay, here we go, and it's going to end. Okay, and now I have the vector 2 and 3 that indeed the vector that are the French one. The funny thing is that if you do the opposite, so if I put FR first, and the country, the predicate on country first, and then the vector. If I do the opposite, I will have a different result, which is normal. And I will explain why. So if I do that now, I have only one result. The reason is that if I put this one first, it's going to find the closest one on the whole set, and then it will be filtered on French. So it find it two record, and probably a FR and a UK, and then we filter on the country, and we have only one left. But if you do the opposite, if you say country first and object then it will first take every record FR and then extract the two closest one, right? So this can be useful for many reasons, but it's related to the way the brute force has been implemented. We try to make it as efficient as possible. So when you filter, we really filter. We try to build the brute force on everything that has been filtered, right? So which is the reason why if you have many models in the database, so maybe if you have a 5 version of your trained data, it means that the size of the database is 5 times bigger. You still will have a brute force implementation that will be pretty efficient because it will really compute it on the filter record, right? So you have the control of this, and so you can make a kernel search mixed with any operator really easily.
Yeah,
so that's what I wanted to show.
No, that's awesome. So we've got a question here from Chovy saying, I can import all the photos from my phone as training data and have it find photos of me. This is kind of how it works, right? But actually, we're not training a model here. Correct me if I'm wrong. We're not training the model. FaceNet is a trained model for face detection. What you're doing is you're passing in a photo of yourself. Let's say you're passing all of your photos from your phone. Then you pass in a photo of yourself, and every single photo gets a numeric vector. That vector determines to a computer what that image was. And then what we were doing later on when you pass in another image is we're matching for the closest vector to that, and therefore finding the closest image. So effectively, this isn't training. Training is a step before this. If you're building your own model, you might want to train it in a custom way and alter the weights of that model or the configuration options of that model. This is once we have a trained model, and there are lots of models out there that you can use off the shelf as well. Then you can benefit from generating those vector embeddings from that model in order to store in the database. So you could pull a vector embedding from OpenAI's API. You could pull a vector embedding from FaceNet. You could put it from an open source model from Hugging Face, right in Python. You can do everything there. So it's not the training, but it does allow you to do what you were questioning. Yeah. Just one other question we've got here on the chat, which is, looks like I might not even need Quadrant or Pinecone additionally for my project. And then this way, permissions and access to the embeddings does not need more work than before. That's exactly the case. So every functionality that you use or might want to use in SteroidDB can sit alongside or above this vector embedding functionality. So whether you want to use permissions or security access, if you want to access directly from the front end browser or in a traditional server-side based way, all of that functionality sits next to this full vector embedding, indexing functionality. So you can use it alongside everything else you're already doing without needing to keep that data consistent with a secondary database system, work out, managing, maintaining, dealing with the network side of things when dealing with a secondary database system as well. So really exciting. Emmanuel, sorry, I'll let you carry on.
Well, that ends my presentation for today. So the next big thing is, of course, HNSW. That is a way, right, to bring the model on scale if needed. Again, if needed, because it's not always the case. What we expect now, I can make a statement about what we expect from you guys and the community, is that with this feature now, added with Cyril ML. I don't know if you want to say more about ML, but ML is typically the mechanism where you get the information from trained models, and that will be the perfect pair, right? When you have ML from Cyril ML, you have this feature that is extracted from information. So you have this vector that is generated that can be then stored, and then you can use the key NN search to get the answer to the question you are asking for. So what we expect from the community now is to start playing with these tools, put vector there, and make queries and give us feedback about what you think about performances, about is it easy to do, is it does it meet the expectation, is there functions missing, is there distances missing, because we try to put all the similarity distances and function that you may need to have to manage those vectors in the database. We try to not put any arbitrary limits. So there was this question about the size of a vector. I think we didn't put any limit, and we also make some benchmark by putting millions of vectors, big vectors with thousands of the dimension. We talk about dimension for vectors, and we talk about dimension like thousands, which go over most of what the model are expecting today. So the idea is really to be sure that you can build those applications and not be limited by that kind of things. So we need feedback. We want you to test it and give us feedback, because it's an open book, something that we continue to improve every week. And yeah. So that was my point.
Awesome. Emmanuel, thank you. I'm just going to finish with a couple of comments from YouTube. We've got a question here. Etienne has got two questions, actually. Well, the first one is, from his experience, HNSW in Postgres offers performance for a correct UX with 1,536 dimensions. So I presume you're working with OpenAI vectors there. I'm not too sure of your question, Etienne. Definitely, HNSW is going to be more performant than exact nearest neighbor search, but obviously you do have other things to consider. You have to build that index with a good amount of vectors to begin with, so that it balances well. And are you running in a single node and a distributed node environment as well? So lots of things to consider. Jump on our Discord if you've got more questions around that, and we'll be happy to answer those. Probably good to start a separate channel in Discord for full text search and vector embedding indexing specifically, but let's do that in due course. So definitely HNSW is going to be exciting. Etienne's second question is, when would you expect to ship HNSW index? So we don't have an exact date for this. We're working on this over the next few weeks, and we expect this to be in a 1.2.0 release, if anything, if just for beta. So really excited. And this functionality itself that you've seen today is already in Nightly, and it's going to be coming in the 1.1.0 release very soon as well. And then one final point from Karim. Thank you. Thank you for following CeruleDB and using it over the last few weeks and months. This is exactly our point, right? Being able to use CeruleDB to build your applications, but also then to incorporate the ML side of things and the AI side of things, whether that's linking in with other APIs like OpenAI or other models, and whether you're working from Python or JavaScript or Golang or Rust, it's really supposed to be flexible so that you as a developer, you as a team or an organization can build applications just far quicker and far more easily without having to think about how you do your infrastructure. And that's the whole point, right? So thank you. Great to have those comments. It spurs us on to build more and more, and makes really work even better. On that note as well, we've had some big performance improvements with some PRs over the last couple of weeks, from the vector embedding side and the full text search all the way to memory leaks and performance improvements around how we store data on disk. So we've got a release coming really soon, and can't wait for you to try it out and give us your feedback. But Emmanuel, for today. Thank you. This has been really interesting to see just how easy it is really to build a facial detection library or integration or platform on top of SurrealDB. So we'll be for everyone who's watched today, will be, or anybody who's watching on YouTube in due course, we'll be putting that demo example into examples repository very soon, so you can try it out yourself. And yeah, let us know your feedback, and we're looking forward to seeing what you can build on SurrealDB as well. So Emmanuel, thank you, and everyone else. See you on the next stream.